Well, thanks everybody for coming. So at Puppet Labs, we've been working to extend our configuration management tools into the network device arena. And our vision for this is to allow you to manage your networking configurations in the same way that you're currently able to do with servers and applications. And of course, by doing this, you get to obtain all the same benefits of the whole infrastructure as code philosophy that's a core tenet of the DevOps movement. So the purpose of this talk is to give you an understanding of what it means to start managing your network infrastructure using Puppet. We're going to go over where we're currently at in terms of network device support, and also some things that are due to be released fairly soon. We're also going to go over some examples of some Puppet manifests that have networking configuration in them. But the goal of this is not to make you all experts in writing network configuration code using Puppet. But rather, the goal is to make sure that you're able to leave here with a very clear idea of where you need to go next in order to get started trying this out on your own networks. And then importantly, too, we're going to talk a little bit about the future of network device automation and where we see some of the kind of cross-vendor standards converging to and how we intend to evolve our support in Puppet in order to leverage that. So just briefly about myself, my name is Scott Garman. I work on the release engineering team at Puppet Labs. And I tend to do a lot of work with our partners as we're adding new supported platforms for our Puppet agent software. My background's actually in embedded Linux development and distro engineering, and this background actually becomes pretty handy because a lot of the new platforms that we've been adding support for tend to be based in some way or another on a customized Linux environment. I work here out of our office in Portland, Oregon, and I really enjoy being part of the thriving tech and open source community here. And in fact, if you're going to be in town for a while, I would highly encourage you to check out the website calligator.org. Calligator lists all sorts of user group events and tech meetups and things going on in the area. And you'll find that practically every day of the week there's a number of events to choose from. So Portland's a great place to be in if you like tech and software, not to mention good craft beer and coffee.
My name is Kris. I work on network engineering for the operations team at Puppet Labs, and also work with engineering on how we can better support network devices. A lot of complaining. I do a lot of complaining. Prior to Puppet Labs, I was actually at the South Pole for 21 months. This was the 40th anniversary of Ethernet. I rounded up some scientists and anyone who was interested, handed them all a patch cord that would freeze in about 30 seconds in place, and we took a picture with a network switch. But more on that later.
Pretty cool story, Kris. Anyway, I'd say that 2015 was really kind of a watershed year in terms of our network platform expansion efforts. And in a way, too, it was also really the first year that we've gotten some pretty significant momentum around the efforts. So what I'm going to do next is kind of give you a walkthrough, an overview of what devices we currently support and also what's just around the corner in terms of support. So first we have Arista Networks. We basically support every switch on Arista's website where they list out all the different switch models that they have. We work with the Arista EOS version 4.13 and later, and you've got to get started with Puppet Enterprise 3.72 or later. The Arista support is all Puppet supported, so PE customers can get technical support with this as they need it. And the support ranges a whole a wide range of products, including things like top-of-rack switches as well as kind of the larger chassis-based switches. In terms of module support, you have two choices when you're working with Arista. So there's the Arista Networks /EOS module, and they kind of wrote that from scratch. And then we have the Arista Networks NetDev Standard Lib module. And what NetDev Standard Lib, we'll probably go into this a little more detail, that's intended to be kind of like an abstracted cross-vendor solution that you could use. So it has maybe a different set of features than what we have in the other modules. So the idea here is to give you some choice so that you can use what's most appropriate for your needs. With Cisco, we just announced our support for their Nexus 9K and 3K switches. You do need to run the latest firmware update for the NXOS, so the version string there, and that was released just earlier. When is it? Is it October or September now?
I'm not sure.
It was released fairly recently in September, and it works with Puppet Enterprise 2015.2 and later, so basically the Puppet server version 2. It also is fully Puppet supported, and the main module that you would make use of is on the Forge. It's Puppet Labs / Cisco Puppet, and as more devices and models get supported, those are going to be included into that module. And also, it's not on the Forge at this time, but you can go directly to the GitHub repository. There's a Puppet ACI module that you can use to configure the Cisco ACI fabric as well. Now, in terms of upcoming support, the Nexus 5K, 6K, and 7K series switches, which are awfully popular, those are well underway in terms of the work in progress, and we expect that to be ready in Q1 of next year. All these solutions, we've been partnering pretty closely with Cisco, and these are kind of considered Cisco-compatible solutions when you're working with Puppet Enterprise. And Cisco has a web portal you can go to learn more at cisco.com/go/Puppet Labs. And then we have Cumulus Networks. And Cumulus is a little bit different from some of the other vendors in that they create an actual distribution that you can install on white box switches. So a Cumulus-based switch could run on something like a Dell switch or a Penguin Computing switch. And basically, they have a hardware compatibility list on their website. And if you go to that, we support everything that's x86-based. And the support requires Cumulus Linux 2.2 or later. And it works with Puppet Enterprise 3.7.2 and later. And they're also part of the Puppet supported program. In terms of the modules, Cumulus kind of split out their modules into kind of like smaller chunks in terms of functionality. So you have everything from license management to port configuration to interfaces and interface policy. When it comes to F5, it's not necessarily all about switches. We also have some load balancer support. And for F5, we support their Big IP series load balancers. These devices actually aren't running a Puppet agent on them, but instead it makes use of what's called the Puppet device model, which acts as, you basically set up a Puppet device server, and this acts as a proxy. And in this case, it's proxying REST commands over to the F5 load balancers. And this has been compatible with Puppet Enterprise 3.7 and later. And this is also a fully supported module. You can find it on the Forge at Puppet Labs /F5. And with Huawei, we've got some work that's in progress right now, and it should be due for release by the end of this year. And this is on their Cloud Engine 12800 series switches, and it will run on Huawei OS 6.0. And this will also be compatible with Puppet Enterprise 2015.2 and later. And the interesting thing about this is our work with Huawei, they're actually going to be shipping the Puppet agent on their switches from the factory. So it'll remove one more step that you have to go through when initially deploying the Puppet agent to these switches. So, Kris?
All right, networking. I love me some networking. First, we're going to talk about, how are we a little different than the systems folks? How could we compare a network switch to a cold, dark place? This photo here was taken in negative 60 degrees Fahrenheit. We have some beautiful auroras, some sunrise, dawn coming in the background. Dawn is a month at the South Pole. And we have all this beautiful scenery out here. The end user of a switch is inside that dome. They are stuck inside that dome because the last 30 years or so, the last few decades, we've been given these wonderful, powerful boxes that do amazing things. If you've ever had the chance to work on a CRS-1, I have not. It's probably a beautiful thing. We have all this great hardware, all these great ASICs. You're given a nice CLI to play in. These CLIs, back in the day, were a little tricky. They gotten better. Juniper helped increase the CLI when they based their system off FreeBSD. But we were stuck in these custom CLIs. We also had limited or no access to the underlying OS. You would never see a bash prompt on a major vendor network device. Again, Juniper did eventually kind of change that. And customer demand is changing this today. We're seeing more Linux-based OSs on switches. We're seeing more openness to getting users to the core of the system. We're getting to see the aurora and the stars and the beautiful dawn. The other thing that's interesting, difference between a lot of the system stuff and us, is we have these protocols that we're driven by these protocols, these neighbor relationships that happen. One vendor's writing based on ETF RFC, another vendor's writing based on that same RFC. You turn those protocols on, and hopefully they talk successfully together in the same way. And if you think about how large the internet is, grasp truly just how much routing is occurring on the internet today. It is just mind-blowing that it all works, and impressive. You have other things such as blast radius. If you're going to automate your entire network, and you push Puppet config to a remote office that publishes a default route into your OSPF environment, you can do some pretty catastrophic damage. So I can see that there's, there's a little hesitation in how far the scope of you want to start off with this stuff. So it's good to start simple. Other things like BGP and MLAG, these are all things that you have multiple devices that have these neighbor relationships. Some are proprietary, some are based on open standards. And then the physical. We have more interesting physical interfaces than servers do. This is a fiber optic link. We had to cut this building and drag it on the ice to move our water supply, so we had to fusion splice this back together. I hadn't used a fusion splicer in 10 years. It was probably made in the 80s and out of calibration, but we made it work. And then this was not actually active, thankfully, but that is a vampire tap in one of the outbuildings. A very interesting physical interface. You have one large coax cable that you chomp Ethernet interfaces onto. But today we have things like QSFP plus ports, where you can split out 40 gig interfaces into 410s, all this kind of more interesting physical interface stuff that you might not see on a server as often. With that said, how are we similar? The convergence between what a router looks like, router switch, and a server they're starting to converge. You're starting to see, we have general purpose CPUs on this thing. We have RAM, we have what you would see on a system. The difference is we're seeing just additional drivers that show those ASICs, expose those ASICs up to us as interface or NICs at this point. Protocols with text-based that are becoming daemons with text-based config files, something that Puppet is great at handling. And more general-purpose OSs. Linux is starting to penetrate the switch and routing market. You're starting to see bash prompts on these devices. Your customers are starting to ask for Python, Perl, and Ruby stacks, and that is a great thing because it's more tools, and Puppet is part of that tool set. That's a great question. We are going to go over some of the types that exist today, pulled from straight-up documentation from the Forge and the vendor modules. This is what you can do on a Cisco Nexus today. That list is growing, and also what's highlighted in red in the upper left, Cisco command config. That is where you can actually define a chunk of a show run as a Puppet type and have that configuration applied to a Cisco. So that is our crutch. That is our crutch while we build out more of these nerd knobs to support more features on these devices. Right now, I've been working with Cisco with their BGP types and providers, and that's in a branch at the moment. So we're waiting on some final review of that, and that branch will get merged. So you'll have more native BGP types on Cisco. Moving on to Arista. Here is the EOS types for the Arista switches. Again, we have an EOS command that kind of gives us we don't have a native idempotent type for that yet. So here is where you can put native configuration in to support that until we have a type for it. And then Cumulus. Cumulus is interesting because this is that convergence of Linux. 15 years ago when I was heavily using Debian, I was like, man, I wish I just had a Debian box with a bunch of ports on it. That is what Cumulus is, and it's awesome. So this may look like a small amount of support types, but if you look on the right, that bold red is Debian-based. The standard libtypes and everything on the Forge, if it's an x86-based switch, a lot of times if it's PowerPC, these types are going to run on that switch. If you want to run an Apache server and a MySQL stack on your network switch, feel free to do so. Have fun with that. If you're running Quagga, you pull Quagga from the Forge and start configuring it like you're running Quagga on a Linux box. So where do we start? Well, network engineers, we like the lab. Somewhere you've got gear in a lab. A lot of these products are starting to have VM versions for them. I know that Cumulus just came out with a VM version of their product. Start mocking this stuff up in the lab. Start running through the prerequisites for what it's going to take to put the Puppet agent on these images. Sometimes, in order for Puppet agent support, maybe the code that's required to run on these switches is too new for your production environment. That happened in one case where we had some Juniper gear running. I was on 12.3, our Puppet agent required 14-something. I was like, I'm not really running 14-something in my production network, but I could play with it in the lab. Incorporate automation into your projects. If you have a greenfield project and maybe it's a new office or some type of hardware refresh you're doing, stop and just think, well, I want to automate all this, whether it's with incorporating the zero-touch protocols with the Puppet agent. Build in some time. If you've got 100 hours to mock this project up and spec it, make it 150 and start writing some Puppet code. Dealing with the blast radius, you can start small with that too. You don't have to go out and start automating your BGP edge routers with 500 customers off them out of the get-go. Start puppetizing syslog. Start puppetizing NTP. Start puppetizing your management plane, your AAA with your users, your SSH configs. These are all things that, if you screw them up, maybe you get locked out of your own switch to get into it. Requires a console cable, but, you're not going to affect customers. Moving on from there, you can go to layer 2 configuration. Start defining your VLANs. Start defining the ports that you want as your trunk uplinks. Start defining the VLANs on those trunks. And one area that we're starting with at Puppet Labs itself is a new out-of-band network. These are switches that are just dedicated to running all the out-of-band stuff, all the consoles, all the management interfaces, some of the PDUs. This is, for us, this is a greenfield network. So it's like, all right, we're going to get some network switches in here that are going to be puppetized, and it's just going to be for out-of-band. And if we have some difficulty with it, it doesn't even affect user traffic in a production environment. So moving on to some actual code. NTP, if you're familiar with Puppet, this is the hello world of Puppet right here is NTP. Looking at the Arista code, basically we're pulling in our types that we're using, we're installing the module, we're ensuring that the module is installed and that Puppet's running, and here is our NTP config. Moving on to Cisco NXOS on Nexus, this is what the same type of stuff would look like. Now, if you remember, you didn't see NTP up there as a native type on the NXOS list. So in this case, we're using our kind of catch-all that was bold and red, the Cisco command config. We did basically in our lab, we do a show run. We're seeing that, this is our NTP config that's actually in the configuration. We're going to put this in the command, and it's going to get pushed out. Cisco has some great details on the caveats of this, and there's not too many. It actually works pretty well. Moving on, Cumulus. You don't really see anything Cumulus in this slide. This is the, Forge NTP module, and we're using the native NTP class, and you would just configure it like you would on your system. Moving on to VLAN trunks for Arista. Again, it's fairly self-explanatory in the networking world here. We're ensuring that it's present, that it's a trunk. We've got a range of VLANs on this trunk and an individual VLAN as well, and it supports a native VLAN. This is a native type on port ETH48 for this switch. Here's what that same code would look like on Cisco. This is a native type for a Cisco interface, ETH1/48. It's our uplink. Again, the same kind of looking code. The type language looks a little different. These are different vendors trying to figure all this out. So you're going to see some small differences in the types. And this is what it would look like on a Cumulus-based switch. Again, a native type, switch port 48 with a native VLAN of 20 there with the PVID.
All right. So getting started, Just as Kris mentioned, NTP is kind of considered the basic building block as you're starting to learn Puppet. So don't necessarily try to start managing ports on your switch. You can start with syslog or NTP or another basic service like that, authorization. Usually the first step, if it's required to have a Puppet agent running on your device, you want to download and install that. So if you go over to docs.puppetlabs.com, take a look at our PE documentation, and do a search for the vendor's name, you'll be able to find out instructions on where to get the agent from and where to download it from. And then take a look at the modules list for the device. You can refer to the slides here. They're intended to be kind of a useful reference. And install the module and begin making use of it. So talking a little bit about where we kind of see things going. There are basically some attempts to create better standards for cross-vendor use of networking gear. And I think a lot of this was kind of inspired by the rise of software-defined networks and the desire for people to abstract things out even further. And we've, in working with a lot of our vendors, especially some of the larger partners that we've been working with, we get a lot of feedback about netconf and Yang. And it seems that this is kind of the direction where things are moving towards. And so what netconf is a transport. It's basically XML RPC over an SSH connection. So you've got some security built into it. And netconf can be transaction-based. So that can be useful for doing things like adding support for rolling back configuration. It supports any kind of data model you've got. And it's got a pretty clear separation in its definition of the configuration state versus the operational state. So it's a very appropriate tool for DevOps environments. So if you want to compare configurations and so on. You pair that with Yang, which is a data modeling language. It's kind of a hierarchical data node representation. You can kind of create trees of data. It's an extensible language. And there are Yang models that exist for things like BGP or OSPF. And basically what we would like to do, I'm not necessarily saying that there's going to be always a one-to-one mapping, but we realize that at Puppet Labs, if we want to try to work with and create some cross-vendor standards, we're probably better off looking to the IETF and the IEEE who created these standards for inspiration. And an example of this was as Cisco was working to add BGP support to their module, we had some discussions and collaboration with them. And we basically took the Yang model for BGP and then based our design on that. And now we have something that's actually also appropriate to probably pull into the NetDev standard lib library as well, which was missing BGP up to this point. So again, we want to be aware of these other standards that are available and leverage them to the extent possible. So where I see things kind of moving towards in the future is definitely going to be heavily influenced by netconf and Yang.
So we're not necessarily trying to turn network engineers to programmers. This is all new stuff for us network engineers, and it's pretty exciting. At the South Pole, it's dark for 4 months, kind of like trying to learn some of this stuff, but the sun always comes back. Thanks. And I guess I talk too fast because we got a lot of time for questions.
Yeah. No, the other thing too is we really want to get feedback from people. We want to know folks in the trenches what they're looking for. A lot of our network device support is something that's been fairly new at Puppet over the last year or 2 years. And so we want to get feedback from our customers, make sure that we're going in the right direction, that we're focusing on, so for example, device models that are relevant to your networks and so on. So we created a PuppetConf Slack channel called NetDev. If you want to pop in there and give us some feedback or email us directly. Chris's, that's your Twitter handle there, PacketChris.
Yep.
And certainly hear your feedback and suggestions. So questions? Do we have a mic runner? Yeah.
Yeah.
I was wondering what the difference is between using an appliance with a Puppet agent installed versus using a RESTful interface like a Puppet module designed to use a RESTful interface into the appliance. Is there any practical difference as a user, as a Puppet user?
Well, as a Puppet administrator, the thing you got to keep in mind is in order to create these Puppet device, basically nodes, is there needs to be a one-to-one mapping between the nodes and the devices that you're managing. So if you have a large number of devices, you have an issue with scalability. And that's something that we have a lot of smart folks at Puppet who are looking at improving in the future.
I think my question is more like, as a hardware vendor, is it better to embed a Puppet agent or to just create an API, a RESTful API?
I think the Puppet agent is going to give you the most flexibility in that case, definitely. And that's what we've been preferring to do whenever possible.
Okay.
So, yeah.
So I have a question. When do you think you will support ACI natively? I saw you do have there, but it's not a Puppet supported yet, right?
Right. Yeah, that's something. So I believe the folks at Cisco wrote the module, and they've been working with us to get feedback, and we just have a few more things that need to get done to that module before it can get to the point where it would be something that we could support. So that's kind of an ongoing thing right now. I don't necessarily have a schedule for that I can tell you about, but certainly if you want to talk with the folks at Cisco and their booth and let them know that that's something that sounds like it's an important feature for you. It is something that's in development, and it's just kind of we're working on a few different projects with them, and that is one of them. Yeah.
On the Cisco Nexus 5, 6, and 7K, how do you guys deal with using ConfSync for redundancy and having the Puppet also controlling it?
ComSync, I'm not running Nexus in production myself, so I haven't done ComSync, but is that something where you're pushing configuration to one switch and it's doing an auto sync to its partner and sort of like the VSS kind of design? In that case, maybe you're treating the Puppet object as the active switch, and you're just letting Cisco do its sync. Now, what happens in a failure scenario? Does the IP address move to the partner, the management IP, if there's a failure? Because in that case, it would.
Management IP, it depends on how you set up
Yeah.
HSRP and stuff.
Oh, okay. Because yeah, I'd have to mock that up. I would think maybe you'd start with just like, well, I have this one object and it's got a management IP and it handles its configuration sync on its failover. If you can turn that off and still run the redundancy protocols like HSRP, you could Puppet manage them individually then at that point. So.
Both Juniper and Nexus, when you're treating them as a virtual stack, you run Puppet agent just once, and it populates the config for the entire stack. It's the same way you do config as a whole. You treat it as one big stack.
Yeah, on Juniper switches in a virtual chassis, it's just one switch basically. So you're running one Puppet agent because it's running. There's one active supervisor or routing engine in Juniper speak that's running the Puppet agent.
So I can imagine if you're trying to package a Puppet agent in an appliance, that would put a burden on QA for the hardware manufacturer. But if you're using a RESTful interface, that would simplify QA. So what would be the advantages of embedding a Puppet agent to the manufacturer?
It generally just makes it easier for, like, we have this issue with, like, what is the first step if you have an existing, a large number of switches. The first step you have to take is obviously to go to each of those switches and install the agent. So having it embedded in the switch already from the factory is something that's definitely advantageous there.
We're also asking that question ourselves, to be honest, because one of the differences on the networking gear is we're built to last as far as replacement life cycles than servers. You have tons of Catalyst 6500s that are still in operation today. There are versions of iOS, classic iOS, that support netconf on those Catalyst switches. So if we did have a method to treat a netconf object that's not an agent running on the catalyst, we could start puppetizing configs on classic iOS devices. So that's not in any sort of pipeline. That's kind of musings that we've been discussing from my perspective and folks that I talk to out there that still have some of these switches. So it's sort of like, netconf yang, is that something that would be an agentless sort of scenario, API, whatever you want to call it. So, again, we're discussing. I'd like to talk to you about it if you want to discuss it.
Every
more.
Puppet agent built to date, I don't know what the NXOS does because I haven't had a chance to play with it, just calls the native providers, whatever they support. So like the NetApps, they call the RESTful NetApp interface to configure it. So what they're doing is each vendor just builds providers that know how to talk to their device through their own API. So I don't think anybody builds providers that actually configure their switch directly. They do it through the APIs they support in QA. And then that way you can QA the Puppet agent, just does it use the APIs correctly? The Puppet providers, really.
Yeah, I think, and even, correct me if I'm wrong, but one of our switch manufacturers, we're getting native Puppet agent running on the switch, but that agent is, the providers are written that I think they're talking netconf to localhost. So, even netconf is involved if we've got a native agent running on it.
And I can add a little color to it as well. Even if you are speaking native API on the agent, the transport is now going through a interface that we understand on the Puppet level, and you're also getting a little bit more performance. So when you gather facts, for example, on a Juniper device, we execute several RPCs to get them from different places, and now we can ship that back as a single response as opposed to 30 different responses. So there are some benefits to having an agent just for that kind of demuxing.
So you have layer 2 and layer 3 support. One of our bigger challenges is the network security policies, on a ASA or a Juniper SSG, SRX. What is the future in that, having firewall devices?
Yeah, right now that's a very vendor-oriented conversation, and I'd like to kind of change that conversation. It's sort of like our answer in the past as well. It's up to Juniper to write the Puppet support for that. So you would ask Juniper that. Well, in some cases I feel that's wrong. Like we should be having these answers as well. Is like the thing about, did you say SSG or SRX or both? Like SRX, we have some SRX at Puppet Labs. They're MIPS based. I don't think we're going to have a MIPS Puppet agent anytime soon. So my answer to that is, well, there's VSRX. So now you're running virtual Juniper products on hypervisors that are x86 based. So now we could start opening this dialogue with Juniper that's like, okay, now that you're on x86, well, that's easy for us to get an agent on. Can we get an agent on that? So that's actually a project that I'm looking at in the next year just for Puppet Labs Corp itself is, okay, do I need to move these SRX hardware platforms to VSRX so that I can have a discussion about a native Puppet agent? So. Yeah, and again, right now, the way our development model is here is core, here is our API to write types and providers for Puppet and Puppet Enterprise. Vendor go do that. So what is the standard network vendor answer? Well, talk to your sales or your sales engineer and get a feature. It's sort of like, should Puppet have a team that helps with that? And again, we're still asking ourselves that question. So, send me an email about that. If you have any kinds of requests like that, because input from users is kind of what I'm lacking at the moment. Is what are these vendors' customers asking for? So SRX, I'm right there with you.
One thing to keep in mind, people, is that this is just the way Puppet works. You just got to think of it slightly differently. The providers should be written by the vendor for the hardware. We should define the interface types, just like all of us have been building new resource types most of our career. So you think about how you want to express the concept, and then the vendors can implement the providers that actually do it. I've actually done providers for some vendors. They're not that hard to do. It's better for us to think about and create the interfaces through the resource types that we want to use than to let them do it. Let them build the providers.
Yeah, and the thing about just, again, the SRX example is as we talk more about netconf, well, I'm running some netconf-based scripts against my SRX today. If we had a Puppet interface to netconf, well, now you could automate that MIPS device without having to necessarily get an agent on it. So, but we just don't have that design in place at the moment. So. For netconf?
Yeah.
For doing netconf?
Yeah.
Okay. I didn't know.
Oh, the JPuppet doesn't run on SRX MIPS.
Correct. At this time, correct. Well, the JPuppet, yeah, you're right. But you can do the netconf providers using Puppet device, too. That's the thing is, you don't have to wait for the vendor. If you know how to build a provider that will make that config change on the unit, make a provider and run a Puppet device. It's the fast way to get it done.
Yeah, again, that's another question we've also been asking ourselves is should we turn our eyes to Puppet device and see about improvements we can make to that as well?
Well, it's a larger question in that
Yeah.
when you're trying to automate a large research application or what have you, these are things that span multiple types of things. I want a firewall rule to go from web server to app server or 47001, whatever I want to do. I need a way to instantiate that in a firewall rule base. Firewall rules are specific in that they need to have, different level of priority. Certain rules are come after certain levels. And it's half boundaries.
Think of the way you want to express that idea. Write those resource types and then hire someone to write the providers. You came back to me with a list and said, make this work, and I just had to make you providers. I can possibly turn that around in a day or two.
Cool. Any other questions? Well, thanks for your time.